everyone. So before we get started, a little bit about myself. I work at Giska Labs. We're a small software consultancy in Helsinki. There's about 14 of us, so we really are quite small. We're really heavily invested in Rails and Ruby. And I've been working there for about 8 years now, mostly on Ruby stuff. You can find me in all the usual places, and you'll notice that around the time when I started my blog, I realized I don't have to name everything after myself. Yeah. So a little bit about myself. I tend to start too many side projects. I sometimes finish some of them. I brew my own beer as a hobby. And of course, because I do that, I had to create my own beer app. So if you're interested in beer, you can go check that out on iOS. I run a book price comparison site. So if you're looking for where to order a physical copy of a book from, you can use this and it'll tell you, search through 6 Amazons, I think, and a couple of other stores, and it'll calculate shipping and currency conversions for you. And I'm currently working on a service called TLS Care, which will alert you if your certificates are about to expire or if they've been revoked. So, a few disclaimers before we get properly started. I'm not a cryptographer. I'm not a hacker of any color. I'm just a developer who wants his apps to be secure. And with that out of the way, on with the show. So what's this talk about? Mostly it's generic web application security stuff. Most of this will apply to almost any web application, except that there are a few Rails-specific implementation details. So, what sort of risks are we dealing with our web applications? Who's our adversary? And at this point, some of you might be asking, why would anybody hack my website? And the short answer to that is that nobody will, but probably some script will try. And the reason why hackers like scripts are the same reason why we all like automation. It increases their overhead, it increases the chance that it will succeed, and the tools are available for pretty much anybody, regardless of how skilled they are. In a report from Sucuri, they found that it takes about a month and a half for a website with no user and no content to be found by scripts. But you might be thinking, there's nothing valuable on my site. But the truth is that every website has something of value, and that is reputation. The attackers can use your reputation to either inject ads onto your page, try and install malware on your users' computers, or just hold your site hostage. So at the end of the day, every site on the web is a target, especially when the attacks are so automated. So that brings us to Rails. At Giska, we really, really like Rails. We think it increases our productivity and lets us do great things for our clients at a fraction of the time it would take otherwise. And we also think that it's a great base for a secure web application. And the reason for that is the sane defaults. So what are those sane defaults? Just on the security front, when you use Rails, you get CSRF protection through the required token. You get cross-site scripting protection. You get protection against SQL and HTML and JavaScript injection. You get some sane default security headers, including X-frame options, which prevents your site from being framed on another origin. You get XSS protection, which activates the Chrome XSS auditor to try and prevent cross-site scripting attacks. And it prevents browsers from sniffing file types automatically. It gives you an encrypted session store. It encourages good development practices, including pushing you towards using good hashed passwords. It encourages you to put your secrets in a separate place, and it automatically escapes user inputs. So you essentially get all of this for free when you're using Rails. And the rest of this talk will assume that you're basically using Rails correctly and you're not doing something really stupid. So what more can we do once we're using Rails correctly? Well, the first thing that comes to my mind is HTTPS. And it's my firm belief that it is, at this point, our duty as web developers to use HTTPS everywhere where it's reasonably possible. Our clients might not demand it. Even the visitors to our sites might not demand it. But as developers, we know better. Even if your site has nothing valuable, do you trust every shady Wi-Fi hotspot someone might be using? And do you trust all the world's ISPs? These are not theoretical threats. Major ISPs are doing things like injecting ads or injecting Notice JavaScript onto third-party pages. In a Google investigation, they found that as many as 5% of browsers are infested with ad injection. HTTPS doesn't just provide privacy and security, it also provides integrity. It dramatically increases the chances that what you serve is what the user actually sees. What's more, starting from the end of last month, both Chrome and Firefox mark HTTP pages with passwords as insecure. So if your site has a password field and is served over plain HTTP, it will be flagged as insecure in the browser. And eventually, Chrome will show a not secure warning for all pages served over HTTP. And if you're still not convinced, there are more technical reasons why you might want to use HTTPS. It's essentially mandatory if you want to use HTTP 2.0, and some browser features required as well, such as geolocation and service workers. What's more, if some third party does mess with your site, visitors to your site won't blame the shady Wi-Fi hotspot. They'll blame your site. So now that you're convinced, how do we go about doing this? Well, first of all, we'll need a certificate. Luckily for us, we can now get a free certificate from Let's Encrypt, or if you're using AWS services, you can get a free certificate there, including wildcard certificates. And also, even if you get a paid certificate, they go for as little as $5 a year, or about 70 Rand. So in Rails, in your production RB, you'll find a setting called Force SSL, and that's your friend here. It'll force all access to HTTPS and set the secure transport security header, which means that the browser will, in the future will always use the site over HTTPS. So I've set up a test site. It's a normal Rails 5 application running on an Ubuntu server, and it's using the default configuration. And as far as we can see, it looks fine and dandy. The browser says it's secure. There's a nice green lock there. But how can we really be sure? Well, luckily for us, there's a really handy free tool we can use from Qualys SSL Labs called the SSL Server Test. We give it our URL, and oh, well, it's a B. I mean, it's not bad. It's a passing grade. But I think we can do better. But how? If we look at the previous screenshot, there's a bit of text there that says, this server supports weak Diffie-Hellman DH key exchange parameters grade cap to B, which is pretty opaque, at least to me. And if you click on the handy Learn More link, we get to learn all sorts of fancy things about logjam and freak attacks and DHE export ciphers and ecliptic curve Diffie-Hellman key exchanges and prime numbers. But luckily, there's a shortcut. We don't need to read all that. Smarter people than me have created the SSL configuration generator. Tell it what server you're using, what browsers you're targeting, and it'll spit out a good SSL configuration for you. We won't get into the details here, but suffice to say, it's better than anything I could come up with. So once we deploy that to our servers, A+. Excellent. And then there's one more thing you can do with HTTPS. You can submit your site to the HSTS preload list, which means that Once your site is included on the list, all the major browsers will automatically use HTTPS to connect to your site, and never HTTP. And there are a few technical requirements, such as serving a valid certificate and serving all subdomains over HTTPS. Right, so now we have HTTPS sorted. What can we do next? Well, for one thing, we could add a content security policy. So what is a content security policy? If we read the Mozilla documentation definition, it says, it's an added layer of security that helps detect and mitigate certain types of attacks, including cross-site scripting and data injection attacks. And I don't know about you, but when I read that, it didn't tell me much. So my definition is that it's a header that tells the browser where it can load assets from. Supported by all the major browsers, including Internet Explorer, as long as you have an X prefix on it. But why would you want such a thing? Well, first of all, it reduces the surface area, or the potential surface area for attacks on your site. It can help prevent malicious browser extensions and malware from inserting crap into your pages. And for example, the content security policy on my piranhas.co has stopped some shady browser extensions from injecting, I think, ads onto the page. And if you probably can't see from there, but something's tried to load a script from static.cmptick.com. I don't know what that is, but when you Google it, these are the results you get. So I'm not 100% sure what that was, but I'm 100% sure I don't want it on my site. So the policies allow for quite fine-grained control over what can be loaded from where. They're set per response, so you can have different pages with different policies. So here's a simple example of a content security policy. It's quite simple. It says scripts are only allowed to be loaded from the same origin as the page itself. And if we extend it a little bit, we can tell it that they're allowed from the same origin and also from Google. There's a number of available directives, all the obvious ones I think of, like scripts, styles, images, and fonts. And there's a whole lot more if you have more esoteric needs. And what's more, you can get reporting, so you can find out what's being blocked, where, and why. And by default, you get a JSON document, but there's a handy free service that gives you a nice UI for reporting the violations. That's where this earlier example was from. So where to get started if you want to add a content security policy? Well, first of all, adding it to a long-standing site can be kind of tricky, because you can't really be sure what's being loaded from where. Perhaps one developer has added YouTube embeds, another has added a Facebook button, so you can't really be sure of everything you need. If you add it to a whole new project at the start, it's a lot easier to get going. So your first content security policy might look something like this. And at first glance, it looks like it's stupid. It allows everything from everywhere. But it actually blocks inline scripts from the page. And if you want to go a bit further, I recommend using the Secure Headers gem. It's from Twitter, and it's made for Rails and Rack apps. And it handles a whole lot of security-related headers all in one. It provides support for the content security header, and it lets you override it on a controller action level. And there's a whole lot more that is too much to cover in this talk. And since it's such a complicated gem, you might be intimidated by it and not know where to start. And I'd recommend just going by the defaults. They're strict, but not ridiculously so. If we look at what the default headers are, it'll add the content security policy, which we'll look at in the next slide. It adds X download options, which mitigates against some Internet Explorer vulnerabilities. And it adds X permitted cross-domain policies, which restricts Adobe Flash's access to data. And the rest are just the defaults that you would have in Rails anyway. And if you look at the content security policy it adds by default, essentially for almost everything, it allows assets from the same origin and over HTTPS. And you might want to add report URI to that as well. So you might still be thinking that this sounds like an excellent way to break your website in unexpected ways. But luckily for us, there's a solution for that as well. It's that there's a report-only version of the header. As the name suggests, it works like a normal content security policy, except that violations are only reported and not enforced. So if you're going to add a content security policy to a new project, I recommend having it from the start. And for old projects, I recommend adding it as report only. Leave it for some weeks and check that you haven't missed any assets you need. So at this point, you might have had enough alphabet soup. Unfortunately, this is the world of security for you. So moving on to a wonderful thing called HPKP. It's HTTP public key pinning. It's another security header, and it lets you limit what public keys the browser will trust in the future. And in my opinion, it's an excellent way of shooting yourself in the foot. If you mess it up, you can lock out visitors to your site for days, weeks, or even months. And if you mess it up on a production site, there is no undo button other than waiting for it to expire. And in my opinion, for most sites, it's not worth it. The potential for damage is way too great compared to the gains you get. However, if you do decide you want to go down that road, I have some tips for you. First of all, start with a very short expiry time, preferably measured in minutes or less. You'll need to include pins for 1 or 2 backup keys, and these backup key pairs should never touch the server until you actually need them. Preferably, you should keep them somewhere offline. And you can also choose to pin a certificate public key or 2, which will get you probably most of the gains because it limits the number of certificate authorities that can effectively issue certificates for you. So, in summary, I think the Rails defaults are pretty good, but they can be easily tightened. You should definitely use HTTPS, and you should test that you've set it up correctly. And to set it up correctly, the Mozilla SSL configuration generator is pretty great. I recommend using a content security policy, if only to reduce the surface area available for attacks. And the stricter it is, the fewer chances there are for third parties to mess with your site. And I recommend using the secure header gem to manage the policy. This requires a bit more thought than the Rails defaults, but in my opinion, it can be worth it. With one big caveat to all of the above. If you're working on your first Rails app, this is probably complexity you don't need to add. And public key pinning is an excellent way to shoot yourself in the foot. But if used correctly, you can effectively prevent a rogue CA from issuing servers for your domain. But I don't really consider that this is a major threat for most people. Thanks, that's actually all I had. Any questions?
Start SSL and pre-SSL certificates. I've always wondered, is there potential vulnerability in those?
Well, Start SSL can no longer issue certificates.
Oh, really?
Yes, they did some shady things.
Like what?
They issued certificates for domains that they didn't authenticate. But Let's Encrypt is reliable.
Is it?
Yeah.
And do you use it on your site?
I use it on my sites. Anything else? At the back?
So how would you use CSPs in an application that runs with an API in the backend, serving JSON to something that runs with something like Angular React? Who looks after the CSP then? Responsibility of the Angular app?
It's the Angular app, because it's a browser feature. It doesn't really affect any other user agents. Yes. It sounds like a great approach, bearing in mind that Let's Encrypt has some rate limiting, so as long as you're not exceeding that, you should be fine. I don't really have a strong opinion on them. I mean, if you need a wildcard, then you need it. You won't get one from Let's Encrypt, so that's one case where you probably have to pay for it if you're not on AWS. But if you need it, you need it. Yep. Yep. Sorry, say again? Yes, that's kind of a different topic. We use Code Climate on almost all our projects now. So that runs Brakeman, and so we get vulnerability reporting through there as well. Plus, there's a whole lot of the other tools that was covered yesterday, like Bundle Audit, and to find out if you have any insecure gems or dependencies. And I think that's still required. It doesn't supersede that. Yes, sir.
Using CSPs at any time can conflict with SEO consideration?
No, it shouldn't, because it's really just an implementation detail of where you're loading things from. Because the search engine doesn't care. It just tightens where assets can be loaded from.
With the key pinning, would that help against like common firewalls where they install their own CAs on computers and essentially man-in-the-middle SSL connections? Would that then prevent connections?
Yes, as long as their mat in the middle doesn't remove the header. If the connection's being mat in the middle, then with a valid CA, then you can't really fight against that too far. I mean, it'll prevent it if they're lazy. The same thing goes for the browser extensions. I looked into it, and it appears that browser extensions can mess with the headers, so it only helps mitigate against like lazy authors. It doesn't mitigate against everything. Well, there's nothing more. Some details again, and some resources you can look up. I'll also post these to my Twitter account as soon as I can. Thanks a lot.